Hi, I'm an old guy and I do maths, and today we're looking at simultaneous equations, or are we? So we've got two equations here, x minus 2y on 4 equals 0 and y equals x on 2 plus 3. Now, if these are indeed simultaneous equations, what we can do is we can either solve them by substitution or, I guess, elimination. My preference is substitution, so what I'm going to do is I'm going to rearrange this equation so that it looks roughly like this, so that it starts off with a y, then has an equal sign, and then some x's or some x's and possibly some integers. So let's get to work on that. Okay, first thing to do, I think, I'm going to do it this way. There are a couple of ways in which you can do this, but I'm going to do the following. I'm going to split the fraction. The reason that I can do this is that 4 is dividing each of these, so I can just quite simply split that fraction. And then I'm going to rearrange this a little bit. Negative 2y on 4 equals negative x on 4. So I've left this in position and I've moved this expression completely over here because this was positive or adding to this side of the equation. I've subtracted it from this, so I must subtract it from this side. Hence we get that. Now, there are a couple of ways in which we can proceed from here. The fastest way, we want to get rid of these negatives. So the fastest way that we can do that is to multiply this whole thing by negative 4. So negative 4 times this will give me 2y equals x. Now, it's a simple rearrangement from here to do the following. Y equals x divided by 2. Now, you can still see, I'll put that into the frame. So from here, I move to here, y equals x over 2. Now, you will notice that the gradients are the same. Alarm bells should ring. The other thing that you can probably see is that there is no way that x over 2 is going to equal x over 2 plus 3. Indeed, it doesn't. So if we were to draw these very quickly on here, this y equals x on 2 would pass through the origin and have a gradient of a half. Y equals x plus 2 would have a similar gradient, the same gradient actually, and it would pass through 3. This is not to scale, but it would look something like this. And these lines would be parallel. So this point here would be 3, and this point here would be 0, but the gradients are the same. The lines are parallel, they never touch, and therefore these two simultaneous equations, if that's what you want to call them, have no solution for x or anything else. They don't touch each other. And the key to understanding that is the two things that I've circled. Now, this is one of the two circumstances in which this may occur, and I'll do an example and put it in the playlist of one where the following occurs. Instead of the lines being here and here, the two lines might have the same gradient, and they might have the same y-intercept. Now, in that case, there is a solution, but that solution is infinite. They always equal each other. In this case, they never equal each other. And that's the lesson to take away from here. Where the lines are parallel, and you can see them both, there is no solution, they never equal each other. Hence the title, Simultaneous Equations or Not. I hope you found that useful. If you did, please like and subscribe, and I'll see you next time. Bye.